Hi, I'm Mr. Huber, and in this video we're going to talk about problem 3. Uranium-235 is a radioactive substance that has a half-life of 2.7 times 10 to the 5 years. So only after 2.7 times 10 to the 5 years it will have halved, okay? Find the amount remaining from a 1 gram sample after 1000 years, and how long will it take a 1 gram sample to decompose until its mass is for the first time below 700 milligrams, which is 0.7 grams. Give the answer in years accurate to the nearest 1000 years. Okay, so first, the 2.7 times 10 to the 5 is just 270,000 years. So if you don't want to use this notation, you could write it as 270,000. Now we need to use the ansatz a of x or t is a times b to the x. So I used t here, but you could have used x. So the initial value is 1. Then the decay factor per 270,000 years is 1/2. So you write it up like this. When you think back to the exercises we did about exponential growth and decay, you will remember that we've done this many times. So after 270,000 years, it will halve the value. So if you plug in 270,000, this will be 1. So it will be 1 times a half, and it will have halved the amount, the initial amount. Okay, so the first question, find the amount remaining from a 1 gram sample after 1000 years. Well, you just plug in 1000 here. Okay, plug in 1000 and you get 0.997 grams, which is not too astonishing because it will take this substance 270,000 years to halve its amount. So after 1000 years, you only go down by a little bit. Now the next question, how long will it take a 1 gram sample to decompose until its mass is for the first time below 700 milligrams, which is 0.7 grams? Okay, so that's the question. A of t, the amount in terms of t, is less than 0.7 grams. How long will it take? Again, we're going to use an inequality. So you substitute this term in here. This is what you get. So we will have to isolate t eventually. But first, we're going to rewrite everything without the 1 because it doesn't change anything. Now, in order to be able and isolate this exponent, we use the ln. So first we write it with an ln, then we can take out the exponent. So this is what we get. Now we divide by ln 1/2. Well, you know what happens. The sign is going to change because ln 1/2 is less than 0. Then you multiply by 270,000. This is what you get. So when you plug in numbers and you type it into your calculator, you get something that's greater, approximately greater than this number, 138,934.75 years. And we were asked to round it to the nearest 1000 years. So that's approximately 139,000 years. So it will take this substance 139,000 years to decay below 0.7 grams. So let's get back to this point where you changed the sign. Look, I would like to explain this one more time. You have your ln function. Goes through 1. This is f of x is equal to ln x. So let's write f bar. because it's the inverse function of e to the x. So whenever you take an x value over here, you're going to get a positive y value. Whenever you take an x value between 0 and 1, like for example 1/2 lives here, you go down and you see you're going to get a negative y value. That means ln of 1/2 is clearly negative. Well, you don't see it when you work with it this way, okay? But well, you could type it in. Look, ln of 1 divided by 2 is minus 0.69 approximately. So it's negative. But well, when you remember this, you can clearly determine that it will be negative. So you're dividing by a negative number, which means you have to change the sign. And it does make a lot of sense, because if you had used equal signs here, okay, you would have got t is approximately equal to this number here. And that would mean, and you would have known that only after this number of years you will have passed, or you will have gone below the 0.7 grams, okay? So I hope it wasn't too difficult. See you in the next one.